All right, so I'm going to go through and we're going to review drawing the Lewis structure by using the Vesper model, determining the number of electron domains, determining the electron group geometry, molecular shape, etc., etc. All right, so let's look at this first problem here. For Ci4, in order to determine the number of valence electrons, I know that carbon has 4 valence electrons, because remember, as we count across, 1, 2, all the way across to 8. Okay, so carbon has 4, iodine has 7 times 4, which is 28, so 28 plus 4 is 32, so I have 32 valence electrons. Then it wants you to draw the Lewis structure. So remember, I already determined my number of electrons, so that was the first thing to count. Then I'm going to share, so carbon is going to be my central atom. I've got 4 iodine, so I'm going to share 2 electrons between each of them with carbon. Then remember, every atom wants 8 valence electrons. So iodine here has 2. It needs 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. All right. Then I'm going to recount again, make sure I'm using 32. And when I count all of those, right, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, I'm good. Now I need to use the Vesper model and make sure this is what it looks like. So after looking at that, we know that it actually looks like this. And if you didn't need to use the simulation, awesome. If you did, that's fine. Just get used to how these guys look. All right, so that was number 2. Number 3, determine the number of electron domains around the central atom. So we've got a total of 1, 2, 3, 4 electron domains, right? And they are all going to be bonding domains, 1, 2, 3, 4. So then what is the electron group geometry? The electron group geometry, therefore, is going to be tetrahedral because I've got 4 electron domains. And since I have 4 bonding domains and no non-bonding domains, that means the molecular geometry is going to be the same. It's going to be tetrahedral as well. For number 6, determine if this molecule is polar or non-polar. So there are 2 ways of determining this. There's the technical way and the non-technical way. Non-technical way, imagine this is a tug of war, and you've got iodine pulling up, this iodine pulling down, down, down. If this molecule does not move, it is non-polar. The other way of imagining it is you have these vectors, right? If they cancel out completely, if the dipoles, we call them dipoles, if the dipoles cancel, then your molecule is non-polar. All right, so looking at this, or imagining a tug of war, these would all cancel. Your carbon would not move. So that means that your molecule is going to be non-polar. And the reason why we say is that your dipoles cancel. All right. All right, to determine the bond order, notice all of the bonds that I have here are single bonds, so the bond order is 1. And then finally, the bond angle for a tetrahedral shape, right, is going to be 109.5 exactly. All right, let's look at the next problem. SO3, okay? So the first thing that I need to do here, I need to count my number of electrons. So sulfur has 6 valence electrons. Looking at the periodic table, oxygen has 6 as well. So that's going to be a total of 24 valence electrons. All right, now I'm going to draw this. I'm going to share electrons. So sulfur will be my central atom. I've got 1, 2, 3 oxygens. Okay, then I'm going to have lone pairs of electrons, so 2 on oxygen already, so 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and then sulfur needs 2, 4, 6, it needs 1 lone pair. So right now I'm using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm using too many, which tells me I am going to need a double bond. So I'm going to get rid of these two lone pairs, and I'm going to add in between them a double bond. Now I'm using 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, and I am good. However, this is a case of resonance where, remember, the double bond does not, and the two single bonds don't actually exist. It's an average of all three of them. So, to answer your question, yes, indeed, you do need to draw 3 different versions of this one molecule. And let's really quickly make sure that the Vesper model supports this orientation. Okay, so clearly it does. We're good to go with that. All right, for number 3, it asked you to determine the number of electron domains. So I've got 1, 2, 3 electron domains here. All right, so since I have 3 electron domains, that means that my electron domain geometry is going to be trigonal planar. All right, and since I don't have any non-bonding domains, I only have 3 bonding domains, that means that my molecular shape is going to be the same. All right, for 6, is this molecule polar or non-polar? Well, imagine I've got oxygen pulling up this way and then pulling this way, pulling this way. That sulfur would not move. Those dipoles cancel, so this molecule is nonpolar. All right. For number 7, what is the bond order? So I need to average all of my bonds. So I've got a double bond, right? And then I've got 2 single bonds for a total of 3 bond spots. So 2 plus 1 plus 1 divided by 3. I'm just averaging their orders. That would give me 4 divided by 3, which is 1.33, or you can keep it as 4/3. So that's going to be a 1.33 bond order. So when I draw a resonance structure that looks like this, what I'm saying is the bond order is 1.33. It's just really hard to show that properly. It's easier to show a double bond and 2 single bonds. All right. And then for number 8, determine the bond angle. Since I have 3 electron domains total, right? And a circle is 360 degrees, since I have 3 of them, that means my bond angle is going to be 120. All right, let's look at the next one. All right, NCl3. Nitrogen has 5 valence electrons. Chlorine has 7, but there are 3 of them. 21 plus 5 is 26. All right. So I am already anticipating what the Vesper model will tell me, and we'll confirm it with the simulation. But just because I've gotten enough practice with these, I think it's going to look like this, right? Where you have your bonded atoms downwards and then a lone pair on top, okay? 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. And the reason why I put this lone pair on top of nitrogen is because nitrogen has 2, 4, 6, and it needed 8, a total of 8, all right? So let's look really quickly, make sure the Vesper model agrees with this. Okay, so that works. Then my total number of electron domains, I've got 1, 2, 3 bonding and 1 non-bonding, which means I have a total of 4 electron domains. So what that tells me is that my electron domain geometry or electron group geometry, since I have 4, that's going to be tetrahedral. All right. However, since I have 3 bonding and 1 non-bonding, my molecular shape is going to be trigonal pyramidal. All right. Now, is this molecule polar or nonpolar? If you notice, chlorine's going to be pulling down, pulling down, pulling down. Nothing's going to be counteracting that pulling back up to cancel that out. So since the dipoles do not cancel, that means my molecule is polar. Okay. For my bond order, I've only got single bond, so that's going to be a bond order of 1. And then for my angle, my electron group geometry or electron domain geometry is tetrahedral, so it's going to be 109. However, since I've got this lone pair of electrons on top, those are going to force the chlorine further down than if it were just a chlorine on top here. So that's going to cause the bond angle to be less than 109.5.